Okay, 7th grade. I'm not here today. I think I told you guys I wasn't going to be here, and I'm running out of time. And so I've got to go through this lesson a lot quicker than I wanted to. First, though, you are going to get a handout from the substitute. The handout is due today. You got to give that to her before you leave. And this lesson here, 7-6, will grade tomorrow. There's no today, so you guys are going to have a long period. I told her that if you guys are well behaved, she could take you out to play and have some free time. But let me fly through this real quick. I got to go through it a lot quicker than I want to, but that's the way things go. So 7-6, this is on page 405. And they're talking about probability of compound events. And so this is this solve and discuss is a good example. It says Talia is playing a game which she must choose option 1 or option 2, and then spin the game wheel, flip a coin, and roll a number on a number cube 1 through 6 for her to win a prize. All the conditions listed she has to meet. So option 1, to win, the game wheel has to land on an S. And as I look at this real quick here, I only see one S right there. The coin is on tails. Well, that's 50-50 right there. I didn't count how many letters here, but there's quite a bit. Odds of landing on an S are pretty slim. And an even number is rolled. Well, on a cube, 1 through 6, we have, 3 even numbers, 2, 4, 6. Option 2, the wheel lands on a Z. As I look at this, I only see one Z, so it's the same odds, looks like. The coin lands on either side. Well, that's 100% right there. I mean, heads or tails, it doesn't matter. And the number 3 is rolled. Oh, okay. Here, just an even number, but here it must be 3. So when you look at compound events and the odds, it helps to make a table. It says you find the probability of a compound event using a table. So this gal here, well, she hasn't won a prize. How sad. So she has to decide between 2 games. Which game should she play? So one of them is flip to win. 2 heads to win a prize. All right. Over here, flip a head and spin to win a prize. Spin blue. So there's 4 options here, or 4 possibilities rather. Only one of them is blue. So here's the first step. Using a table to determine the probability of winning a prize, and flip to win. Heads. So if she has 2 heads, is one possibility here. She's flipping 2 quarters here. And another possibility is 1 is tails and 1 is heads. And then another possibility is heads and tails. Or tails and heads, I should say. Or tails and tails. So when you're flipping these 2 quarters, there's 4 possibilities or 4 outcomes. And that's what they say here. And there's one favorable outcome because she has to win 2 heads. So that's 1 quarter or 25%. Well, let's look over here real quick. Step 2, use the table again. So if she flips a heads and spins a red, it's going to be red and heads. Or it could be red and tails. Yellow could be yellow and heads or yellow and tails. Blue, blue and heads, blue and tails, and so forth. Green and heads and green and tails. How many possible outcomes are there? There's 8. How many are favorable? Well, she has to flip a head and get blue. So blue and tails wouldn't work, heads would. So there's one favorable outcome out of 8. So 1/8, that's 12.5%. Well, I'd rather have this one. So let's look at the try it at the bottom here real quick. It says the designer of Flip and Spin creates a new game using 5-section spinner as shown. How does the new spinner change the probability of winning a prize? Well, using the 5-section spinner, the probability of winning a prize becomes 1/10 or 10%. It is less likely that a player will win a prize when using the 5-section spinner. Well, that makes sense compared to a 4-section spinner. So the convince me down there, it says, what generalization can you make about the number of sections on the spinner and the probability of winning a prize while playing flip and spin? Well, as the number of sections increase, the odds of winning decrease. Yeah, makes sense. All right, example 2. Tree diagram. I'm just going to let you guys look at that example because, again, I'm running out of time here. To try it, they asked the question, is it more likely that a coin flipped 3 times will land heads up exactly once, or will it land heads up exactly twice? Well, neither. Each probability is 3/8. A coin flipped 3 times will land heads up once, or will it land heads up twice? Each probability is 3/8, neither one. Example 3. The names of all middle school students with attendance are entered into a drawing for one of the 2 tickets to a baseball game. This year, Angie, Phil, Mark, and Carly, and Josie attend school every day. What is the probability that Mark's name will be drawn to win one of the 2 tickets? So it says make an organized list of all the possible outcomes of the winners of the 2 tickets. So if Angie wins the first ticket, it could be Angie and Phil, Angie and Mark, Angie and Carly, Angie and Josie. And so the question is about Mark. So there's one. Mark could win that one. Here's another possible outcome. If Phil wins the first ticket, Phil and Angie, Phil and Mark, Phil and Carly, Phil and Josie. Well, there's Phil and Mark. There's Mark again. So that's another possible outcome. And so they do that with all the students. And of course, if Mark wins the first ticket, if his name is pulled first, then it could be him with any of these 4 students. So there's 20 possible outcomes, if you count them all up. Out of the 20, 8 are favorable, because there's 4 right here, and then 1 on each of these. And so the probability of Mark winning one of the tickets is 8 out of 20, or 40%. Try it down to the bottom. Does Mark have a greater chance than Carly of winning the tickets? Let me read that again. Does Mark have a greater chance than Carly of winning the tickets to Carly? Yeah, maybe I'm going too fast. That doesn't make sense to me. So explain the probability. Well, for both, it's 8 out of 20. They both have the same odds. That's true for all the students. Okay. Not worried about the central question. Number 2. What do you know about the outcomes of a compound event displayed in an organized list, a table, or a tree diagram? Each model shows the complete sample space of a compound event. I also scratched out number 3. Number 4 I circled. You can see that here. And number 5. Oh yeah, I did this. So the table shows the possible outcomes for flipping a coin and spinning the pointer of a spinner with 4 equal-sized sections labeled 1 through 4. So if you flip a heads and then spin and land on 1, heads land on 2, heads spin 3, heads spin 4. So there's the 4 options. If you flip a coin and you land on a tails, well, you could spin it and end up with a 1, or a tails and spin a 2, tails spin a 3, tails spin a 4. And they asked the question, what is the probability that the pointer will stop on 3 and the coin will land on a heads? Stop on a 3 and land on a heads and 3. Well, there it is right there. How many possible outcomes are there? 8. So it's 1/8. So you would write it, the possibility, and then in parentheses, 3 and heads, or maybe you put heads and 3, it doesn't really matter, is 1/8. That's how you would represent that probability. So B says, what is the probability that the pointer will stop on an odd number and the coin will land on heads? An odd number, looks kind of blurry. Couple odd numbers there, and heads all the way across. So probability, and then parentheses, odd number, comma, heads equals 2 out of 8. There's 2 odd numbers in 1, 2, 3, and 4. which reduces down to 1/4. Okay. Let's see here for number 6. I filled out the first box for you, 2 and 4. This is worth 1 point to get both of those. For number 7, I've got a tree diagram here, and again, I filled out the boxes 2, 12, and this is 16 2/3%. This is the fraction I'm looking for in there. I circled number 8 and number 9. Number 10, number 11. And so I set this up for you. Draw a tree diagram to represent the sample space. So what is the probability that the free shirt will have either long or short sleeves and will be either pink or blue? All right, I scratched out 12.